Welcome for this mathematics lesson. We're going to handle probability number 18. An examination involves a written test and a practical test. The probability that a candidate passes the written test is 6 out of 11. If the candidate passes the written test, then the probability of passing the practical test is 3 out of 5. Otherwise, it would be 2/7. Part A, illustrate this information on a tree diagram. So we have the passing of a practical and also the passing of a written test. And these are exclusive, these are mutually exclusive events because a student can still pass in a practical when he had not passed in a written test, in the written test that is. Therefore, let me begin by saying we can use W for the written test and say a student can handle the written test and they pass, and the probability of passing is 6 out of 11 in the written test. That means failing in the written test is 5 out of 11, because passing and failing in the written test are two mutually exclusive events. Therefore, their probability should give us 1. Now, when a student has passed in the written test, he goes now for the practical, and he can pass in the practical or fail in the practical. Passing in the practical, when a student had passed in the written test, is 3 out of 5. That means failing becomes now 2/5. Failing in the practical. If he had failed in the written test, he will still proceed for the practicals. So in the practicals, he might still pass or fail in the practical. And passing in the practical when he had failed the written test is 2 out of 7. That means failing when he had failed in the written test, failing in the practical is 5 out of 7. So we have a passing and passing. We have passing and failing. We have a failing but passing in the practical. Then we have failing in the written and also failing in the practical. So these are the probability, the possible outcomes. Those are the possible outcomes. So this is called a tree diagrams. That is a tree diagram, a list of all possible outcomes. In part B, now we are told to determine the probability that a candidate is awarded credit for passing both tests. So probability passing in both. Probability passing in both equals to probability you pass in the written and also in the practical. And this means 6 out of 11 and 3 out of 5. So we can compute this, and we will have 6 by 3. We divide by 11 by 5, yeah. This is going to be 18 out of 55 as a fraction. That is the probability that a student is credited for passing in both tests, the written and also the practical. In part 2, determine the student probability that the student is awarded a pass for passing the written test. Passing the written test. So for passing the written test, we can have two possibilities there. It can either be passing in the written test and also passing in the practical, or probability passing in the written, but when we go to the practical, the student fails. So, but at least we want the student to have passed in the written test. So we can have those two possibilities. This is going to be 6 out of 11 followed by 3 out of 5, or means addition 6 out of 11 followed by 2 out of 5, which means now failing in the practical. So this is already 18 over 55. We're going to add 12 out of 55. This is going to be 18 over 55 plus 12 out of 55. We're going to get 6 out of 11. So this is going to be the probability of passing the written test. So passing the written test has two possibilities. Either you pass and also pass in the next, or pass in the written but fails in the next. But at least we are saying probability passing the written test. The next is retake for passing one. Probability that the student is awarded a retake for passing one test. For passing one test. Passing one test. So when we get back to the possibilities, passing one test, we want the chances whereby it is only one test which has been passed. So it can either be this, passing in the written and failing in the practical, or you fail in the written but you pass in the practical. So these two. So it's going to be probability. It's going to be probability you pass in the written but you fail in the prac, or probability you fail in the written but you pass in the prac. So when we substitute this, we're going to have 6 out of 11 times 2 out of 5, or failing in the written, which is 5 out of 11, but you pass in the practical, which is 2 out of 7 for that matter. So now we're going to have, this is already 12 out of 55. Now the other case is going to be 10 out of 77. 10 out of 77. This is going to be 12 out of 55 plus 10 out of 77. This is going to give us 134 out of 385. So this is the probability that the student is awarded a retake for passing in one test. Passing in one test. Strictly passing in one test can be either of the listed probabilities. Now in the last part, we've been told to calculate the probability that the student is awarded a fail for not passing the written test. Probability that the student is awarded a fail for not passing the written test. Not passing written test. Not passing the written test. Not passing the written test. So not passing the written test has two possibilities. You can fail to pass the written test, but you pass in the practical, or you fail to pass in the written test, but you also fail in the practical. So those two chances, those two possibilities. So it can either be probability, because we want probability not passing the written, so failing the written but you pass in the prac, or probability you fail in the written and you also fail in the prac. So this is going to give us failing in the written 5 over 11, but passing in the prac 2 over 7, or failing and you also fail, in the practical. which is 5 out of 7. So this is 10 out of 77. Or means addition, this is 25 out of 77. So now we can come up with this addition. 10 over 77 plus 25 out of 77. This gives us 5 out of 11. 5 out of 11. That is the probability that the student did not pass in the written test.